Hello, so in today's video, we're going to answer question 14 from the 2021 Paper 2 A-Level Maths exam. So this is the mechanics section of the AQA exam. And it's this question here, question 14. So a motorized scooter, is traveling along a straight path with a velocity of v over a time of t seconds as shown by the graph below. So the velocity increases, then decreases a little bit, and then increase again, and then decrease and decrease, kind of like in this curved fashion here. So Nusha says that in the period 12 to 36 seconds, so between 12 and 36 seconds, the scooter travels approximately 130 meters. Determine if Nusha is correct, showing clearly any calculations you have used. So remember that when we've got a speed time graph or a velocity time graph, so velocity on our y-axis, time on our x-axis, remember that it's the to get the distance traveled, we want to find the area under the graph. So remember that velocity is the rate of change of displacement. So that means that displacement is the integral of velocity with respect to time. So it's the area under the curve. So we want to go between, if I just draw like a straight line, so 12 seconds, so that's 10, 11, 12. So we want to go up to 12 here and read that thing there. And then we want to go to 36, which is here, and read what we get there. And we want to work out an approximation for the area under this. And hopefully it will be about 130, but we'll see what we get. Now, what we're going to do, or one way that I think I'll probably do this, is kind of use like a trapezium rule, use like a set of trapezia to estimate this area here. So what I'm going to do is again just draw a straight line. So I'm going to take this point here and draw a straight line down there. So we got like a trapezium here, and we're going to use that to approximate this distance travel between 12 seconds and 18 seconds. And then I'm going to do the same up here. I'm going to, let's take a trapezium here. So let's take this one here. So I'm then going to estimate the distance traveled in this part, working out the area of that trapezium there. So between 18 seconds and 26 seconds. And then I think, let's just do the trapezium here. I mean, actually, let's break it down into into two more trapeziums. So let's do a trapezium there. So that's going between 26 seconds and if we just get the line correct, so 26 so 26 seconds to 31 seconds, and then we'll do one more trapezium going from 31 seconds down to 35 seconds there, and that should give us quite a good approximation. Okay, so I'll call this number 1, call that number 2, call that number 3, call that number 4. So the idea of this question is we just want to get a rough approximation for the area under that. So I'm just going to use these 4 trapezia here. So we've just got to be careful. We can't use the trapezium rule with this example that I've cooked up here, because the actual heights on the x-axis are different for each trapezia. So I can't use that formula. So I'm just going to have to work out the areas separately. So we start with number 1 first. So the area for number 1, again, using our formula for the area of a trapezium. So A plus B, so like these two lengths, divided by 2, and then times by the height there. So the height of this one there, I mean, all of these squares on the y-axis go up in 0.2s. This y value is 0.2 off of the number 6. That's going to be 5.8. So 5.8 plus this height there, which is 1, 2, 3, 4. So that's 4 below 6. So 6 take away 0.8. That's going to give us 5.2. So yeah, 5.2 there. Divide by 2, and then times by the height gap. So 12 up to 18, that's a height of 6 there. So what we've got is 5.8 plus 5.2. That's going to give us 11 over 2. So 11 over 2 times by 6. Well, 6 over 2 is 3, so that's going to be 11 times by 3, and that will give us 33 for that one there. And then we can work out the area number 2. So again, we've got 5.2 there as our like our A value there. We've got a B value going up there to be so that's 1 square above 6, so it's 6.2. So plus 6.2, divide by 2, and then times by our gap. So we're going from 18 up to 26. So that's 8 there. So we got 5.2 plus 6.2. That's going to be 11.4. Times by, well, 8 divided by 2 is 4 times by 4. That's going to give us, I think, 45.6, isn't it? Yeah, 45 point. Sorry, let me write this again. 45.6. So that would be that area there. And then we'll go to the next one, number 3. So that area. So again, we've got this like height there is 6.2, and then plus this height there, which is looks to me again to be 5.8. So 5.8 divide by 2 times by the height gap. So 26 up to 31. That's 5. So 6.2 plus 5.8. That's going to give us 12 over 2 times by 5. Half of 12, that's 6. 6 times 5 is 30, so that's about 30 there. So 30 meters for that part. And then part 4, again, we've got this height of about 5.8. So 5.8. And then times by this value there. Now 4 is here. It's 1 less than 4, so that's going to be 3.8. Sorry, there should be a plus sign here, my bad. 3.8 plus 5.8, and then divide by 2 times by our height gap. So 31 up to 36, that's 5. So 58, sorry, 5.8 plus 3.8, divide that by 2, so 5.8 plus 3.8, that's going to give us 9.6 in it. Yeah, 9.6. Divide that by 2 times by 5. Half of 9.6 would be 4.8. 4.8 times by 5 should give us 24, shouldn't it? Yeah, 24 there. So 24 meters in that part there. So then our total area is going to be that plus that plus that plus that. So our displacement, our distance traveled, I'll just call it distance. Is going to be 33 plus 45.6 plus 30 plus 24. I'll just do this on the calculator very, very quickly. Get the calculator up. Sorry, 1 second. There we go. So we got 33 plus 45.6 plus 30 plus 24. So we're going to get for this, when we do this, 132.6 meters. And that is approximately, I mean, it's pretty close to 130, isn't it? So it's approximately 130. So therefore, I mean, to me, Nusha is approximately correct. So we would say with this one, it does travel approximately 130 meters. So Nusha is correct. So Nusha is correct. So that's how you would do that one. You just want to get an estimate for the area under your curve, and that area is going to be your distance traveled, which in this case is approximately 130. That's how you'd answer this question 14 from the paper 2 exam from 2021 in the mechanics section of the AQA paper.